Yeah, g'day, and welcome back to my bandsaw repair channel. The reason for the repair was that it was jumping out of gear, and it's jumping out of gear for three reasons. One is this heavily worn out shifter fork. Two is the lack of a detent in the shifter drive mechanism to hold it in gear. And three was excessive wear in the shoulders of the selector dogs. Now last week, I made a couple of castings out of bronze, and these are repair components for this gearbox. So let's go ahead and machine them and get them working. Now while I was doing the castings of these parts for this gearbox, I did notice that the transition duct for my furnace blower is looking in pretty crap condition with a lot of air blasting out here. Now this is a part that I printed in PLA years ago, and it sits in that dark brown garden shed which gets pretty darn hot in summer, so you can see it's warped really badly. There was supposed to be sort of a interface bit on the end of it which somehow tied in with this steel biddy. Can't remember how that was supposed to work. It broke off straight away, so it all got taped together. When they sent me my printer, Bamboo Labs sent me a roll of ASA, which is like a high temperature, very resistant to everything plastic, which is great for sort of outdoor use, chemical resistant and stuff. So I figure this would be a perfect job to test it out. Well, that seems to have come out quite nicely. Nice smooth surface finish. Guess only time will tell how this particular plastic holds up to that horrible environment, but we'll give it a go. Now I think the steel bit was just put on the end with a bit of tape to isolate any heat transfer back down the burner tube from melting the plastic. Man, that's one seriously ugly piece of machining, isn't it? Best quality, $5 for 10 rolls electrical tape, which is really perfectly heat resistant and ideal for this kind of application. Not. Anyway, let's get into machining those parts for the gearbox. Right, first stop's pretty easy. Just need to get this set up to drill out this mounting hole. I guess that's why you have a brass drill, which are ground with less front rake, I guess you'd call it, on the cutting edge here, just to prevent them grabbing in like that into brass. But I don't have any. I mean, I could grind this back, but it's such a nice new drill, I don't really want to waste it. Nah, change of plans. Before I ruin my nice casting, I think I'll transfer this over to the milling machine. Right, now for reasons which will become clear in some future video, my Maho milling machine is currently set up as a horizontal, so it's going to be vice and vice here. Right, well after a bit of nudging and playing around, I think I've got this nice and parallel to the axis, so let's start off just by doing a very light facing cut and seeing what it looks like. Well, a horizontal mill being used like this is not the easiest thing in the world for visibility, is it? That was only a 0.2 millimeter cut and it's already cleaned it up pretty nicely. I'll just take another 0.3 off to take it up to a total of a 0.5 millimeter. Right, I'll just use an end mill to bore that hole. Good, that seems to have worked. Nice. Slightly off center. That was a calculation error. With the burrs gone at 76.5, but I calculated the center off half of 75.5. Because I'm going to have to tweak these to fit around the shifter anyway. I'm guessing I'll just have to tweak it and make it slightly asymmetric. So with that flipped, I'm now going to just go back to my indicator and make sure that it's parallel again. Yeah, that was all within 1/10 of a millimeter, which is going to be fine for the tolerances of this thing. This needs to end up with a nice running clearance on this gap. I think I'll just sneak up on the fit. Yeah, so the bottom one's a sort of a sliding fit. And the top one still tightens up and nips up. So I think I might leave it at that for the machining, because I still need to polish off the machining marks with a bit of sandpaper. So I guess I'll use that to bring this down to its final clearance. I'm guessing a nice tolerance for this would be about 1/10 of a millimeter. Yes, so this is what I've been working on, and it's made out of pure gold.
Oh, this is pretty cool. And you're gonna wear it on a necklace like a rapper?
With this now roughed in, I'll probably still need to do a bit of filing just to get this to fit perfectly. It's a bit too tight at the moment. But before I do any more there, I think I'll make its drive arm and just check the alignment within the gearbox. So in this part, which I don't think is original, somebody welded this together, but obviously I'm not going to weld onto bronze. I've seen that DoAll's replacement forks just have a bolted joint here, so I'll do the same. Therefore I need to make up a new shaft. So the existing shaft is 5/8 of an inch with an M10 thread on the end of it. Now last week I got a bunch of comments on my jumping backwards and forwards between Imperial and metric measurements. Now it seems not everyone's quite as comfortable of just jumping around like I am. So what I would suggest is a very good training documentary from SNL. I'll leave a link up here in the top right hand corner. That should help you out with it. I guess the only change I'm going to make is just putting a threaded portion out the side, and also because this is only 5 millimeters, but my fork is thicker at 6 point something, 6.75, I'm going to need to move the shoulder back by about half of that. So what size do I actually need here? Original was 5/8, but it's definitely grown a bit since then. Okay, so it's only 6/100ths under 16 millimeters. So 15.94. If I make the shaft with a bit of clearance at like 15.9, that should work perfectly. Right, now we just need to make one. Beard lube always helps. So I'm probably going to have to move that a couple of times, so I think I'll take off the soft jaws since I don't need them at the start and they might cause a bit of run out. Although with that rusty steel I'm going to get a bit of run out anyway. Next up comes a little relief groove for the thread. Goes on fine. It's a wee bit rough. I might just chase it with a die. Also just make sure that this drive component fits. Okay, it doesn't. Sliding fit on the original. Okay, that ain't 10 millimeters. Also not. The original nut. Nope. Okay, so my guess is the original is not 10 millimeters, but probably 3/8 of an inch, which would make that probably 3/8 UNC. So 3/8 UNC would be 16 TPI, which that sure looks like. So what do? Do I just ream this out to 10 millimeters, or do I cut this thread off and rethread this to 3/8 UNC? Maybe that's also a little bit too long. What the hell, if it's too long and the wrong diameter, let's just chop it off and redo it. Now this is a really cool feature which Andy Pugh's added here. If I want to do an Imperial thread, all I need to do is put in here, instead of 10 millimeters, put in 3 divided by 8, 3 inches. It converts it automatically. Pitch, I want 16 TPI, and it automatically calculates my pitch as well. And the threading automatically calculates the root and tip dimensions from there, and starts off by doing the major diameter pass first before it starts doing all of the threading passes. Very clever. Thanks a lot, Andy. That's better. Probably should have set this up better because this is running quite out of round, but then again, it's really not that relevant as a feature. It's not going to make any difference. So this mic'd up with my nominal here, but being a bit of a long overhang, I've got a bit of taper. So I'm nominal, about 3 over and about 7 over at the end. I'm going to do a very slightly tapered pass and see if that'll clean it up. Unfortunately, this is going to be a very rubbing sort of cut. I'm probably going to destroy the surface finish. Okay, well that went better than expected. Obviously there's a bit of a rub once it came out of the taper, but let's have a look. So that's now miking about 1 over nominal. Yeah, no, it's pretty consistent all the way through now. Let's just try this out and see if it's actually going to be a nice fit. So this new shaft mics up about 3 to 4 hundredths of a millimeter larger than the old one. Oh yeah, that's nice. Nice sliding fit. Definitely taken away any slop that was in there before. Luckily this week, one of my oldest mates from New Zealand, Hamish, has come to visit me, and he decided he wanted to play David Attenborough and do like a wildlife film of me and my natural environment. What other films has David done?
Wasn't he in Jurassic Park?
Jurassic Park's probably less dangerous than me working with a CNC lathe, isn't it?
Definitely.
You know, it's interesting. Anytime I've got somebody else here in the shop, or if I'm trying to film somebody else, like when I did shop tours with Luke or with Stefano, I realized that I've got absolutely no experience whatsoever in how to direct people. My normal workflow is I start with a rough idea of what I want to machine in that week, but I've got no real plan of the video, no script, nothing like that. So I'm starting off from scratch, doing my mechanical stuff. As I think of thoughts, I'll speak over and say them. Maybe I'll come up with a story that fits into the thing. But by the end of the week, in my head, I end up with quite a clear idea of how this will edit together. As soon as I try and do an interview with somebody else or involve somebody else, all of those skills kind of go out the window. I notice when I'm interviewing somebody else and filming at the same time, it's really quite difficult to have the mental capacity to actually listen to their answers and remember their answers. And because you're not doing that, when it comes time to editing, it's like, oh wow, I've never heard any of this ever before. Almost like a completely different skill set as soon as you move beyond doing this on your own. Sometimes it's difficult having a camera in the way. Then I get right in here and actually see what I'm trying to set up to, which is probably why I don't actually film everything. But I do manage to catch most of my bigger mistakes. Now, one thing people don't really appreciate, just how often you have to change camera angle to make interesting videos. If I'm hitting the record button on my camera for the third time in the same location, I'm at the latest, then I've got a voice in the back of my head saying, move the camera. Keep things interesting, try and change angles constantly. Somewhere along the line, I don't know where, years ago, I picked up that you should change angle by 30 degrees horizontally or vertically for it to seem like a different scene. So a big thank you to Hamish for coming to visit. I think I'll probably leave the behind the scenes stuff to Kurt and Karen at Cutting Edge Engineering. Right, so now that I've got a defined end on this bar, if I take this out, I can now measure the entire length, because this dimension from here to that shoulder needs to be 60.2. Now that I've got a defined length, it'll be easy to set that up. So this is measuring about 80.8, so I'll set it up, touch off there, and then put a shoulder at 60.2. So I'll just use a carbide end mill with a 10mm diameter. I'll set my tool offset. So this should now be a nice fit on this. Maybe I might just need to ream that a little bit, but it's definitely going to be a good fit. Right, ready to cut a thread groove. The next thing we need is a chamfer on the front end. So I think I've just got a bit of a burr down in here. Just run a reamer through it with the hand. Right, well with that now done, it's time to move on to this. So what am I trying to achieve here? This is the shifter shaft and it wiggles around in this bracket. I would like it to wiggle less, so I'm going to make it go through a bronze bushing that will restrain it more. And the second thing is I want a detent so it latches in each of the high and low gears. So this feature is going to be the basis of putting a detent into the system. But first off, I'm just going to flatten off the ends. Okay, that looks like it's exposed a fair bit of porosity. Certainly not the nicest, cleanest casting I've ever done. more nasty porosity on this side. Wow. Oh, I didn't tighten it. Right, now I'm going to need some way of mounting this block onto this. I need the 15.5mm hole through there, and I'm guessing I'm going to put 2 screws, one right here and one under there, which bolt this together. So what order do I do this? I'm kind of thinking it might be easiest to first bore out that hole using a 4-jaw chuck. At the same time, use the drill press to drill the 2 holes into the bracket, and then I can use that bore which I've turned to hold the block aligned to the bracket. So I can transfer punch these holes through into there and then just drill and tap them. Right, well that setup finished. Right, now to mount that block onto here, I'm going to need a couple of holes. Okay, that's going to provide a bit more support. Next up, the detent. A detent needs a ball, and I've got this worn out bearing which came out of the DoAll's blade guides. Let's chop it up and release a ball. Both my number one fan Nico and also Heather keep pointing out how much they enjoy sparks and angle grinding in my videos. Well, my angle grinder, it feels your love. Chopped in half bearings make really quite practical parallels for spacing things in a vise. They're very accurate. Right, so here you can see what I'm aiming for. It's a 5.5mm ball, 6mm spring, and I'll hold it in place with an M8 screw. So I'm going to need to drill right through, but not entirely into the boss with a 6mm drill. If I can leave just a little bit of a lip, then it'll kind of restrain that ball from falling in if I pull the shaft all the way out. Very difficult to get a decent feel when I'm going to break through here because of all the inclusions in the casting. It's a very bumpy ride. Oh, I wonder if that was it. Well, that actually worked well. It caught and jammed just as it broke through, which means I do have that little lip that I want. So I'll clean up that inside burr and see how deep the ball can sit in there. I'm just going to see if I can clean it up a little bit with this end mill, because it's not quite through enough yet for the detent ball to engage. Okay, we're not quite there yet. Game over. If I have to disassemble it, the ball's going to fall out. I hate drilling brass. Well, that's deep enough anyway. Now I can thread it. This reminds me, how many mice does it take to screw in a light bulb? 2, but don't ask me how they got there. Okay, so that still turns and moves nicely. It feels like the ball's going to do a nice detent. At this point, I don't know whereabouts on the shaft I need to put the little detent holes for the ball to fall into. So this is now finished until I've got the gearbox back together. Well, since I had to pop over to Tucson, Arizona for work this week, that's about as much as I was able to get done. But hopefully next week I can finish off grinding those dogs, get the gearbox back together and test it again. Thanks a lot for watching.